Let's do another example using empirical rule. So we have the distribution of the lengths of bolts has a bell shape, so there's important information there, with a mean of 4 inches and a standard deviation of 0.007 inch. So remember our mean here goes in the middle, and then I'm going to add 0.007 to go to the next one, so and keep adding 0.007. And starting at 4, I'm going to subtract 0.007. And then again, I'm going to fill in my percentages. So 34, 13.5, 2.35, and 0.15. Just to remind myself of those percentages. So 68, 95, and 99.7. So it says about 68% of bolts will be between what length? So that is 3.993, so 1 standard deviation away. That's for our units, so inches, and 4.007 inches. Okay. So B says what percentage of bolts will be between 3.986 inches and 4.014. So again, let's mark our values here. So between 3.986 and 4.01, so that's 2 standard deviations away here. So 2 standard deviations away, there is 95%, right? So C says if the company discards any bolts that are less than 3.986 inches or greater than 4.014 inches, what percent will be discarded? So again, let's mark what we have here. So we have less than this, going that way, and then greater than this here. Right? So we're looking at the 0.15 plus 2.35 on that side plus 2.35 plus 0.15, or we also know that we're looking at 100 minus 95%, whichever way you want to look at it, and there's not one set way to do these problems, so whatever you find to work best for you there. So D asks what percent will be between 4.007 inches and 4.021. So again, I'm going to mark this here on my graph. So we're looking at between here, these two values, so between, right? So we have that value from our, from ones. So between these two, right? So that percentage here is 2.35. We have 2.35% here. So just another example using empirical rule.